Greetings and welcome to the Introduction to Astronomy. In this week's Astronomy of Other Cultures, we continue our look into astronomy of the Muslim world, and we'll talk about Omar Khayyam and his contributions to astronomy. So, Omar Khayyam lived from 1048 to 1131. And he worked on poetry, which is honestly one of the things he's better known for, but also did work on astronomy and mathematics. So a number of different things, and we see this with a lot of early scientists, is that they had their hands in a lot of different things and were not just focused on one specific topic. So one of the things he worked on, and let's take a look at his mathematical contributions first. So in mathematics, he came up with the theory of parallels, which really was leading to the ideas of non-Euclidean geometry. Now, if you've studied geometry, most likely you've studied Euclidean geometry, and that is geometry of a flat plane. And that's where things like angles of a triangle add up to 180 degrees, and parallel lines will never meet. However, that's not always the case. And in fact, you can do spherical geometry on the surface of a sphere, where the angles of a triangle are always greater than 180 degrees, and where parallel lines eventually converge. So it's a completely different type of geometry that we're leading toward there. He also looked at things like cubic equations and the solutions to cubic equations, different methods of being able to solve those, as well as doing work on the binomial theorem, expanding a binomial out and looking at different ways that would work. Now, in terms of astronomy, what he did primarily, and the thing he's best known for, is leading the group that worked on the calendar reform, to reform the calendar. This required detailed observations to be made. And the Jalali calendar that came out of this is a little different than the Gregorian calendar, which is used in the West. In fact, it was a 33-year cycle with 8 leap years. So it's different than the typical 4-year, every 4th year being a leap year that we're used to in the Western calendar. However, this is actually slightly more accurate than the Gregorian calendar that came out hundreds of years later. The difference here is that you're looking at 4- and 5-year increments and having leap years not evenly spaced. They might come a year earlier or a year later to kind of tie everything together and to get things close together that really have no reason to be. Because the reason that we have things like a leap year is that it takes 365 and about a quarter days for the Earth to orbit the Sun. And what that means is that there's that extra quarter day that we have to make up for every year. And if we don't, then the calendar slowly drifts. So we add that leap year in every once in a while. Now, if it was exactly 365 and a quarter, be easy. Every 4 years, leap year, and you're done. But it's actually a little less than a quarter. So you have to make these leap years a little different. And that's the calendar that came up here that is still currently used in some parts of the world. So let's go ahead and finish up with our summary. And what we've looked at here is we talked about Omar Khayyam, who lived from about 1048 to 1131, known well for his work on poetry and literature, but we really looked on his mathematics and astronomy sections. And he was responsible for leading the group that developed the Jalali calendar, still in use today and actually slightly more accurate than the Gregorian calendar that is often used in the West. So that concludes this discussion of Omar Khayyam. We'll be back again next week to talk about another astronomer of the Muslim world. So until then, have a great day, everyone, and I will see you in class.